Okay, this is section 4.1. We have 8 minutes to get this done. Students, you're going to be able to graph exponential functions, explore how changing parameters affect the graph of an exponential function. In other words, these are like the same thing as parent graphs. You're going to have vertical stretches, horizontal shifts, all that stuff. So in this problem, the graph crosses the y-axis at 0, 1. Why is that? Let's do a little t-table. So here is your exponential growth. If x is 0, what's anything to the 0 power? It is 1. So the graph crosses the y-axis at 0, 1. So if this was y equals 3 to the x, it's still going to cross at 0, 1. If it was y equals 4 to the x, it's still going to cross at 0, 1. Okay, the only thing that's going to change that is if you put a number out front of the b, which we'll do later. Okay? When b, this is the base, when your base, b, is greater than 1, the graph rises. In other words, it's called exponential growth. Okay, so for example, once more, if let's say we have a problem f of x equals 3 to the x, and we're doing a t-table, you put a 0 in here. Oops, this is x. This would be 1, and if you put a 1 in here, 3 to the first is 3. So your graph would look like this. There's your 0, 1, and then 1, 3. So it looks like that. When your base, b, is less than 1, which, by the way, it's never going to be negative, it's just less than 1, the graph decreases or it goes down. This is called an exponential decay. So what do I mean by b is less than 0? Actually, here's an example of b is less than 0. See this right here? These numbers are going to go down, and I'll do one of these in here in a second. The domain for all these exponential functions is going to be all real numbers. So you can say all the reals, or you can say negative infinity to infinity. And the range is going to be all the y's greater than 0, or you can say 0 to infinity. And that will only change if you have a different horizontal asymptote. So in this simple form, right here, simple form, the asymptote is going to be y equals 0. This is the horizontal asymptote. So when I say the range, this is never, never, never can it equal 0, because that is the asymptote. And we'll go over that here and right now. All right, so here's the problem. Graph by hand and verify the characteristics of the graph with the bullets above. Okay, so if x is 0, you remember this is 3 to the x, this is 1. So you go 0, 1. I need an x-axis in here. I'm going to draw x-axis right. Oh, wait, I think I just found the x-axis. This is not it. The x-axis is right here. So 0, 1 is your first point. Okay? If you plug a 1 in, what's 3 to the first? 3. So 1, 3. If you plug a 2 in, you're going to get 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what if I plugged in, say, a negative 1? 3 to the negative 1 is actually 1/3. So that's over here. And you could plug in a negative 2 and get 1/9. That's even smaller, but it's never going to be negative. So basically your graph looks like this, and that's what exponential growth looks like. Okay, and the reason it's an exponential growth because 3 is greater than 1. Okay, next. Now, the base. Notice the base, 1/5, is less than 1, so this should be a decay. So I'm about to show you what a decay looks like. First of all, if you plug in a 0, 1/5 to the 0 is 1. If you plug in a 1, 1/5 to the first is 1/5. So you have 0, 1. It's right there. But 1 to the 1/5 is right here. So I'm not doing any more positives. I'm going to plug in negatives. So what is 1/5 to the negative first power? Let's remember this. If you have 1/5 to the negative first, it means that 1 is to the negative first and 5 is to the negative first. So basically, a negative 1 is called a reciprocal power, which means if you have 1/5 to the negative first, it is really 5 to the first. You just flip it over. Or you flip them like this. Either way, it's going to be 5 over 1. So negative 1 means that this is a 5. So negative 1, 5. So what do you think negative 2 is? Negative 2 would be 1/5 to the negative second, which 1/5 to the negative second means that you would flip over 5, the 1/5. That takes care of the negative. So it's really 5 squared. So flipping this over, the negative means flip it, and then the square means square. So this is 25. So it'd be negative 225, which I can't even graph because it's off the graph. It's way up here. So this problem looks like this. Your horizontal asymptote is still 0. And that's what a decay looks like. So this is a decay. And this is a growth. Okay, questions? All right, graph by hand and explain how the characteristics of the bullets above have changed. So 1/4 will, what? 1/4 does a vertical compression. The 2 means that your horizontal asymptote moves up 2. Okay, so if I did that, my new asymptote is here at 2. So everything's going to be above this graph. So before we had a 1/4, 3 to the x, that's it. So instead of 0, 1, it would be 0, 1/4, because you're going a fourth of that movement of 1. So 0, 1/4 is like right here. Instead of a 1, look up here. What's 1/4 of 3? What's 1/4 of the 3 modes? So instead of going over 1 up 3, you're going to go over 1 up a fourth of 3. So 1/4 times 3 is 3/4. So 1 3/4. So 2, what's 1/4 of 9? It would be 9/4, which is 2 1/4. So 2 1/4. So it's just going to go up a little bit slower, but it's still going to be a growth. You can punch this right into your graphing calculator. It's not that big of a deal. I just need you to know that because 3 is greater than 0, it's a growth. Because you have a number added, that moves your horizontal asymptote up 2. Those are the 2 things you need to remember about this problem. All right, so this is your whole parent graph right here. Okay, so this is where the graph differs from this form right here, a, b to the x. This is your parent graph, a, b to the x, by translating the graph. So this, you're going to go right or left by h units, depending on what this is. So if it was like a x plus 3, you'd go 3 left. If it was this, you would go 3 right. Okay, so that number tells you left or right by h units. And then the k moves your horizontal asymptote. So you're going to go up or down k units. Up or down k units. This moves your, so the k is your horizontal asymptote. There is no vertical asymptote. So h is not your vertical asymptote. It just moves everything over. Like instead of 0, 1, if this was my problem, my first point, you would, instead of 0, 1, it would be 3, 1. Okay? So here we go. Predict how the graph of B will differ from the graph of A. Verify your prediction using a graphing calculator. So here's the parent graph. Okay, so I'm just going to quickly say that I'm always going to have a point at 0, 1. And if you have a 5 to x, it means if you put a 1 in, you should get a 5. And it looks like that. So how does the second graph change? Well, this 3 means we're going to move it right 3. So you're going to go right 3. So see how this point was 0, 1? It's now 3, 1. And you see where this point right here was 1, 5? It is now going to be 4, 5. So you move both units over 3. Oops, I forgot to do the 2. And then you have to go up 2. So I forgot. Let me do that again. So we're going to go up 2. That's your first thing. So usually you have a point at 0, 1. But in this case, it's going to be over 3 right there. So you can punch in your graphing calculator and just look at that. I'll let you guys do that right now. An example 4. So this just tells you that you have a vertical stretch of 6. So if I let this be 0, it would be 6 times 3 to the 0, which is 6 times 1, which is 6. Your first point would be 0, 6. Just keep in mind, your first number is usually 0, 1, but you had a vertical stretch of 6, and now it's 6. The second number would usually be 1, 3, right? If you have a 3 to the x, it would be 1, 3. But you would go up 6 from there. So you're really going to go up to 9, 7, 8, 9. Keep in mind that this looks something like that. Oh, that is just totally wrong. Forget what I'm saying here. This goes up like this. Horizontal asymptote is still 0. Yikes. I'm going to graph that for you just so you can see. 6 times 3 to the x. So it's still going to have a horizontal asymptote of 0. I was drawing that wrong. But you are going to have a point at 0, 6. See how it kind of goes? Instead of going through 0, 1, it goes all the way up. Can you see that? Instead of 0, 1, it goes up at 0, 6. But it has the same shape as the other ones. So what do you think? This is a terrible graph. So what do you think this does? This means that it is a reflection over the x-axis. So instead of being above the x-axis, this means you're going to be below the x-axis. The 3 still says it's a growth. But this plus 1 means you're going to go left 1 and then down 4. It says what you would need first is your horizontal asymptote. You're either going to be above this asymptote or below. In this case, because the 6 is negative, you're going to be below this. So usually it looks like this. So reflection looks like this. So usually it goes like this, growth. But it's a reflection, so yours is going to go like this. So we just need some exact points. I think we're just going to punch this in the calculator. So you have negative 6 times 3 raised to the x plus 1. If you have an old calculator, you get to put parentheses around your exponent here. Minus 4. So it's going to be below this asymptote. So this looks like it's almost is the asymptote, and then it goes down. So you just need some points, right? So we're going to get some negative points. So press second graph. I like the point negative 2, negative 6. So if I had a graph, I'd go negative 2, negative 6, and then I like negative 1, 10, 7, 8, 9, 10. And maybe like negative 5, a little over negative 4. So that's good enough for me, and it looked like this. So that negative out front just reflects it, but you still have a horizontal asymptote of negative 4. So what happens if you have an a, b to the negative x? This automatically is a decay, and the reason that is because this negative is called a reciprocal key. The negative exponent is a reciprocal. It means flip the base. Flip the base. A negative does. So if I saw something like this, b to the negative x, I would flip the b to 1 over b. And then I would change it to positive x. So whenever you see a negative, flip it to its reciprocal, 1 over b. Now this is a decay because the b is less than 1. Since b is less than 1, it's now a decay. So decays, sometimes they're negative exponents, sometimes they're with fractions inside. So if you saw this problem right here, this would be a decay. Okay, it's still got a horizontal asymptote of 0. My first point, if you let x equal 0, has a vertical stretch of 2. Usually it would be 0, 1, but in this case it's going to be 0, 2. 2 times 3 to the negative x. So if you plug in a 0, you get 2 times 1, which is 2. If you plug in a 1, you get 2 times 1/3, which is 2/3. So that goes down 1 and 2/3. You really only need 2 points to draw these curves. That's what the first one looks like. So what does the second one do? This one's kind of tricky. 2 times 3. You got to take a -1 out of this. So the 2, well, it's the same as this 2, so that you don't even have to mention that. You would have a horizontal the negative right there is a reflection over the y-axis. If the negative is out front, it's a reflection over the x-axis. But if that negative is with the x, it's a reflection over the y-axis. That's the first thing. And then it's 2 to the right. And then you have a horizontal asymptote of -1. In other words, down 1. So if I was graphing this, just before I even graph it, you have a horizontal asymptote of -1. There's that. It's 2 to the right and a reflection over the y-axis. All right, so the 2 part would be down here. That's the reflection. Okay, I'm sorry, it's a reflection over the y-axis. So this one would be over here. So my guess is like this, but it's right 2. So if you take this point, right 2. So it's going to be over here. I'm going to graph this. So we have 2 times 3 parentheses. Let's do this again. 2 times 3 raised to the -x plus 2. Watch very carefully. This is going to have a horizontal asymptote of 1. And it's going to reflect over the y-axis. If it graphs, there it goes. I don't like that this does not reflect over the y-axis. -x plus 2. I'm not sure why I'm wrong on this. It probably is reflecting. I'm just not seeing it. Press this graph again. So let's look at some t-table points. So find the nicest numbers. So you got 1, 5, and 2, 1. Let's look at 1, 5. 1, 2, 3, 4, 5. Three, -1/3. And there you go. I'm not quite sure why I can't explain this, but that's it.